Given these integrals, find the value of each of the following. So let's do this. Here we go. Let's read through some things, and you don't have to do all this, but I'm going to just kind of create a visual for you here as I read through this stuff. So let's just draw things. We're going to draw the f function. So this will be f of x, the graph of f. What does it look like? I have no idea. We're just going to make some stuff up. The area from 4 to 10, we'll call it 4 to 10, is 19. Okay, so there's some function. We're just going to let it be some little purple function that does something like that. And the area from 4 to 10 is 19. That's good to know. Okay, this is giving us a visual. The area from 10 to 13 is 11. Now, it doesn't have to look pretty or look like it's to scale. We're just using this as a reference, so 13. And this area is 11. And the area from 13 to 12, wait, that's backwards, is -5. So we'll deal with that one in a minute. That one's a little crazy. And then we have the g function as well. So the g function is the area, g of x, from different graph. Put them on the same axes if you want, but that's going to be really hard to visualize. And we'll let this one be green. So just getting a visual for all that's going on here. And there we go. Different coordinate plane. 4, 10, 13. And the area from 10 to 13 for the g function is 14. And I'm just drawing this so you can visualize what's happening. We know the area here, 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 and there's something crazy going on here. So let's kind of jump in. Just predicting a few things. They might ask, and I'm not sure, I haven't even looked through the questions that I typed way back in the day. But they might ask, what's the area from 4 to 13? Well, you just add those together. Or they might say, what's the area from 10 to 4? You'd be going backwards, it would be -19. Things like that, okay? So let's proceed. And I'm gonna fix a typo that may or may not be on your paper, depending on what version of this you have. So there we go. The area from 12 to 13, well, I'm looking at this. You don't have to draw it every time, but the area from 12 to 13 is no, because I had 10 to 13, but then there's a 12 in here as well, and then you go from 12 to 13, and I'm not sure what's this little area right here, because the big purple one is 11. But from 13 to 12, it was -5. Okay, well, here's the deal. Using a rather obscure property of an integral, if instead of going from a to b, I go from b to a, we'll just reverse it, change the sign. So this is the same thing as the opposite of 13 to 12, f of x dx. Okay, well, that's fantastic. This is the same as that. Just reverse them. Regardless of which one's higher, which one's lower, you can reverse it and change the sign. Beautiful thing to do. Well, the area from 13 to 12 was -5. So what I really have is -5, which last time I checked was +5. Okay? Next one. The area from 4 to 13 of f. Notice what letters we're dealing with. These are f's, and we got a lot of f's. We'll get to a g down here in a minute. But the area from 4 to 13 for f is, well, you can look at it graphically and tell that we're going to add the 19 and the 11. I kind of predicted that would happen because I forgot what questions I typed. And so, yes, it's 30. Let me write it a little bit differently, though. This would be the same thing as the area from 4 to 10 of our function. Don't forget all the notation. It is important. Don't just start writing integrals without dx's and functions and those kinds of things represented as well. And then 10 to 13, f of x dx. Okay, well, the area from 4 to 10, you don't have to go through all these steps. I'm just showing you how the properties come in handy. From 4 to 10, it's 19. And from 10 to 13, it is 11. And that is indeed where we get 30 from. Okay, the area from 4 to 12, sorry, 4 to 12. I say 4 to 12, I'm pointing at 12 and 13. Whew, long day. The area from 12 to 13 is, and then 4 f of x, well, let's just factor the 4 out. This is another one of those properties. 12 to 13, f of x dx. You can just factor the 4 out. I'm writing a lot of steps that can happen in your head, but it's the first time you've seen these properties formalized, and that's why we're doing this. So I know the area from 12 to 13. We actually just found it a minute ago, and it was 5. It was the opposite of this one. So it's 4 times 5, which of course is 200. I'm kidding, it's 20. Okay, now things get tricky. We're going to do a lot of really cool stuff on this next one. We're going to use several properties, and yours are on the other side of the paper, mine's on a separate piece of paper, but because we're adding, we can break it apart into separate integrals. See, look familiar. Because we have that scalar, we can bring it in the front, which we just did. That's this property right here. We have a constant that we can factor out. So we're going to do a lot of stuff on this one. So this turns into, let's factor out that 4. And we're going to go from 10 to 13 f of x dx plus the integral from 10 to 13 of 3 dx. Okay, now you can find everything you need about this one right here, and it's 11 times 4. So we have 4 times 11 plus, what in the world? What is this? I don't want to blurt out that the answer to this piece is 9, because I really would hate to ruin the fact that it's 9, but I want to explain why it is what it is. Okay, we did this in this same lesson. This is the area under the graph of 3, but it's from 10 to 13. It is this graph, 3, but it goes from 10 to 13. So from 10 to 13, I'm making this up, it would be 3 wide and 3 high, and that's why it's 9. If you need to visualize this, feel free, here goes. You do not have to graph this, but from 10 to 13, we're going to have a 3, and here's our graph, and it's purple, and it goes from 10 to 13, and that looks like a rectangle. It's not a square, but it's a square. It is 3 wide and 3 high. So sometimes they don't give you what you need, but they just say, hey, find the area of this shape, and it's like a rectangle or a square or something pretty basic. So 3 times 3, and later we'll figure out how to do the ones that aren't so basic. So 44 plus 9 is 53. Okay, next one. I don't even want to help you with the next one. You're on your own. Number 6. I'm not telling. I'm just not going to tell. The next one, we're going to use lots of different properties. There's a lot going on here. Let me tell you what I noticed. 1 minus, so we can subtract some integrals. We're going to have like the integral of 1 dx and then the minus the integral of f of x dx. We're going to do that. And here's what else I noticed. This 10 to 4 is backwards from what I'm used to. I'm used to seeing 4 to 10, not 10 to 4. They don't have to be in order, but I'm going to eventually, not now, put them in order. In the meantime, let's go 10, 4. Good, buddy, like a CB radio. The area from 10 to 4 of 1 is what? Okay. It's the same thing as, we're moving forward here, the same thing as the area from 4 to 10 of 1 dx. You can leave the 1 out, it's understood. I'm going to put it because I like him there. But it's the same as this, only you change the sign. And then we're going to change this sign. Well, it was minus, so now it's plus. It was subtraction, so now it's addition. F of x dx. Okay. Running out of space. What's this one? Okay, well, it's negative something, but let's ignore the negative and just figure it out. Good, plain, common sense, Graphy McGraffersons here. From 4 to 10, and the graph is 1, just 1. So horizontal line at 1, what's the area of that rectangle? 6 wide, 1 high, 6 times 1. I'm actually going to write 6 times 1 for those that look back at their notes and they're like, where did you just get a 6 from? It's this rectangle. And then the area from 4 to 10 of F, haven't dealt with G yet, by the way. We'll get to that one later. Area from 4 to 10 of F is 19. They said so. So, see, there it is. So plus 19, and that's going to give me 13. Okay, number 5. I'm kidding, let's not. All right, number 7, couple things I noticed. We can factor a 1/2 out. Also, this thing is in the reverse order that it should be, so we're going to turn that around and change the sign. F of x dx. And we want the area from 4 to 12. Okay, well, we want negative half the area from 4 to 12. We don't know what that is, actually. We haven't found it. We have no clue what that is. So we're going to find it. and we're going to do negative half of it. Here's the deal. The area from 4 to 13 was 30, but we don't know the area from 4 to 12. Now, we can look at our visual and figure it out, and we're going to, but I also want you to consider that we probably need to work through some notation as well. So 30, no secrets there. And let's just be real honest with ourselves. Number 1, from 12 to 13, and I'm going to make it red so it's not quite the same, was 5. So 30 minus 5, the final answer is negative half of 25. So negative 12.5. We'll cross that bridge in a minute. Let's move on. Here's what's going to happen. We're going to do negative 1/2 of the integral from, oh, we never did 10 to 12. That's okay. Let's go 4 to 13 of f of x, which we do know 4 to 13 of f of x was 30. And I know you're like, well, we just did this on the graph. I see it. I know what you're saying. But now we're going to add to it. Let's put that negative 1/2 in the front. There we go. And then we're going to add to it, or even maybe subtract from it, depending on your point of view, this 5. So it's like, okay, you remember, of course you do. If I could find the piece of paper I'm dealing with. Remember this one? When I say, oh, B is between A and C, it doesn't have to be between them. Check this out. As long as I put things in the right order. I can go from 4 to 13 and then go from 13 back to 12, and it will subtract this off. Okay, again, I know you're like, 30 minus 5, I'm not stupid. I hear you, I'm not either. We got this. The sun's shining through the window, illuminating this lesson. Now, but here's the deal. I can do the integral from 4 to 13, I'm having a hard time saying it, 4 to 13, plus the integral from, going backwards now, 13 to 12. It is the same property here. I could, if the B was out here, I'd say A to B, and then B to C, and going backwards would just basically negate this area right here. It works, and that's exactly what I'm going to do. Get all my random papers out of the way. Plus the area from 13 back to 12 of f of x dx. Okay, let's move on with the sun shining in. Negative 1/2 of, okay, 4 to 13 is, we found it was 30. That's been established a long time ago. And then 13 to 12, not 12 to 13, is negative 5. And we're back where we were when we saw it visually. But it's not always going to be practical to have the visual for it. So negative 1/2 times 25, which as we established like a day ago, is negative 12.5. Okay, on to number 5. I'm kidding. Number 8, 13 to 10 of f of x minus g of x. I'm bothered that this is backwards. I mean, it's not wrong, but I'm just going to twist it around and change a few things all at once, okay? So we're going to have, I'm doing a lot here, all in one step. The integral from 10 to 13 of f of x minus, I'm wrong by the way, I'm about to fix some stuff, 10 to 13 of g of x. Okay, here's what I did, and it's wrong, but we're about to fix it. I said, oh, I'm subtracting, let's break them apart into 2 separate pieces. But I also turned these around. Instead of going 13 to 10, I want to go 10 to 13. Well, if I'm going to do that, that changes this sign and that changes this sign. Now it's correct. Let's move on. Okay, negative area from 10 to 13 of f, that's 11, plus the area from 10 to 13 of g, now we're finally using g, it's 14, 3. Okay, let's move this thing to integral 10, 13, g of x dx. Don't forget your dx, like I did here. Oh no, the math police come busting in the room. We know what you did. You're coming with us. You forgot your dx. It's an honest mistake. No, sir. There are no mistakes in mathematics. All right, area, sorry, I got carried away there. The area from 10 to 13 of G, look at the top of the page, it's 14. We're going to double that. And then the area from 10 to 13 of F is 11. That gives me 28 minus 11, that is 17. All right, last one. Don't cry because it's the last one. Or is it? You're like, what is it? You got this. You know what it is. I don't want to give it away. 10 to 13 of F. Don't forget your dx. It might seem unnecessary, but it is so important. It really tells us what variable we're dealing with, even though it may seem obvious. And when you get to higher mathematics, if you leave it off, you're going to be lost. When you get to Calc 3 and you have multiple dimensions and more than just flat surfaces, and you have to like nest these inside each other with the integral of an integral, and then don't be scared, it is so much fun. Seriously, Calc 3 was my favorite. Loved it. So practical. Here we go.
Good evening, parents. We appreciate you for coming out to our family engagement night, also known as cultural night. Right now, this time, we'll have our parent workshops or parent information.
10 to 13 of G.
Also, parents, please scan the QR codes outside of
Well, I'm almost done, and she's making an announcement. Anyway, these came from the directions at the top. These came from the directions. All right. This.
And then at 6 o'clock, we'll have senior meeting information in the PAC, which is the Performing Arts Center. And also, we'll have selling a lot of souvenirs. And we'll have Zoo School in Walker Commons. And we'll also be flying drones and a live band at Walker Commons if you would like to come out anytime soon. We appreciate you coming out to our family engagement night. Go Blue Commons.
All right, this blue comment's going to finish this problem. We're finding the area of the rectangle from 10 to 13 that is 5 high. At this point, I would like to think that you can look at these and just figure them out and say, oh, it's 3 wide, 5 high. So 3 wide, 5 high, I know what that is. I know it's 15, but just in case you're looking back through your notes later and you're like, oh, I don't know what I'm doing. Anyway, 40, that's it. We're done, or are we? There we go. We went from 4 to 4. You traveled no distance at all. It's the world's skinniest rectangle. I actually do want to give you a visual for it. So there's some function. It's f. And you don't have to draw all this, but it's at 4. And I want to know the area of that line. It's a line. There is no area. I said that earlier, but now I'm giving you a visual for it. There they are.